Assalamu alaikum dear students. Hope you are doing good and utilizing this time very effectively for your studies and other businesses. So as you know that in today's video lecture the voice was not audible. From my side it was very clear, but it might have happened during the uploading process. So let us do it again. I decided that I will make the new video regarding the same topic. So it was question number 5 from your text exercise, that prove that perpendicular at the point of contact to the tangent passes through center of circle. So first of all I will explain it to you what the question, what we are supposed to find, supposed to prove. If this is a tangent, if AB is a tangent at the point of contact, here say P, and if we draw a perpendicular at point of contact P, suppose we draw a TP, we draw a perpendicular at P, say TP. What we are supposed to, this TP should pass through center of circle. What does this mean? If we produce this TP, it should pass through the center of circle. Produce means in a straight way. So how will you prove this? It is a very simple. This question, there are three. We can do this question in three different ways. Today I am going to show you one way, and anybody among you, if he is interested in other two methods, please let me know. I will make the video for those two videos also. So let us proceed. First of all we will write the given is what? Given is TP is tangent at the TP is tangent to the yes, we will write given TP is perpendicular to the tangent of circle with center O and radius R at the point of contact P. Given is TP is tangent, TP is perpendicular to the tangent of the circle with center or radius R at the point of contact P. To prove TP passes through center of circle, to prove TP passes through center of circle. So let us prove it. We'll write proof. I'm sorry I have here the unavailability of the space, because you know it very well. So I recommend you, please, before writing the proof, before proving this question, pause the video at this time and note it down. I will give the clear picture of this. So I hope you will understand this problem. So let us prove it. We will write a proof. We will write angle APB equals APT equals 90. Why? This is given because TP is tangent. This is given as TP is perpendicular. This is given as TP is perpendicular at P. Now look, recall the theorem 9.1. Tangent or radius at the point of contact is perpendicular on tangent. You know it very well. So it was the theorem 9.1. If this was your tangent, if we join point of contact with the radius, here the angle is 90. So tangent at the point of contact is perpendicular on radius. So this is your radius. This is your point of contact. It means this is perpendicular. Is it? Of course, this is by theorem 9.1. So we will write angle OPA equals 90. Why? Because radius at the point of contact is perpendicular on tangent, or tangent at the point of contact is perpendicular on radius. Please mention it. Please mention it yourself. Mention it. So let us add up these two equations. We will write angle APT plus angle OPA equals 90 plus 90. Angle APT plus angle OPA equals 180. Angle APT plus angle OPA, this means this whole angle, this angle plus this angle, this whole angle, this is how much? 180. So if you were asked a question, draw an angle of 180, how can you make this? What does 180 angle look like? Take a look. This is your 180 straight line, is it? This is your 180. So that means when you have to form the 180 angle, you will form a straight line. You will form a straight line. So what does this straight line means? That all the pointers on this line, they are collinear. Collinear means those pointers which lie on the same line. It means that OPT is a line. It means that OPT is a line, or we can say that O point PT, they lie on the same line. So it clearly shows that when they are in the same line, it means that PT passes through. Oh, simple. So it means that OPT is a line. OPT is a line. This is a straight line, OPT. Or we can write, or pointers OPT are collinear. What does collinear points mean? Those points which lie in the straight line. So if this point and this point lies on straight line, means this PT, it passes through center. Simple, because O is the center of this circle, so it passes through center, which clearly indicates, which in turn means perpendicular PT passes through center O. That proves your question. So I hope you will get it. It is a very simple question. So how will the concept behind is, you have to prove that this OPT is a line. You have to prove that, or they are collinear. So if this is a line, that means definitely this PT will pass through O. I will explain it again. For example, if we have 3 pointers, this point, this point, this point. Suppose let us name them point A, point B. Suppose we have another point T and we have another point S here. If we are if we produce this, if we are asked that after producing this line, this AR will pass through which point? Does it pass through T or does it pass through S? Let us produce it straight. So it will pass through S. Whenever you produce a line, it means you have to produce it in a line. So it passes through S, not T. You can have produced it, but then it will not remain a line if you produce it in this way. So I hope you will get it. This was the question number 5. This was all about the today's video lecture. I hope you will get it. If you still find any difficulty in regarding this, in understanding this, please let me know. I will explain it to you again. Thank you, class.